then you want to look up Snapchat. The site that I use for my system is 11 seconds. See people just go through like there's like a Slenderman one where I got my sketch, where I got all the
First thing I'd like you to write this down, like on the top there somewhere. There's like some blank space up here. Probably be good. Write these down. We've kind of talked about like mu, X bar, P and P hat, but haven't really made a big deal about like making sure they're correct. But now that will be a big deal to make sure that you're labeling them correctly. So a sample mean is mu. It's really just a U. I'm just like writing a fancy one. Oh, jeez, that's backwards. Don't write it yet. Don't write it yet.
Bless America!
I ruined it.
I ruined it!
I'm gonna go back and listen to this.
Switch everything. Can't find my marker. Hold on. Alright, so the biggest thing on this sheet is I'm just trying to make sure you understand the difference between means and proportions, and then also samples and populations. So means is just average, means looking for the average. Proportion is a percent. So depending on the way, basically for the rest of the year, every question is phrased. The first thing you got to decide is, are we working with means or are we working with proportions? If we're working with means, you're going to be looking at X bar and mu, and if you're looking at proportions, it's going to be that. So again, mean is just if it's an average, and proportion if it's a percentage. That's it. People sometimes try to make it more complicated, but that's really all it is. So, found the average ACT score at Milan High School, mean or proportion? Mean. So you see the word average, that's mean. That's that simple of a thing. But I want to go through it to make sure we good. I'd like my marker to work too. If I just keep doing that,
It was on.
I know. It won't like switch to.
You need to corner thing where you set the corners together.
It would tell me if I needed to. I don't know. It's connected because it's like moving on the screen, but
Maybe the color's white.
why does everything have to be about race?
I know, that's why it's
Yeah, I know. I don't know why this isn't working, but that one means right. We want the percentage. So what's that? Proportions. As soon as you see the word percentage, it's proportions. What are you saying?
just use a dry erase.
Well, the video doesn't really
Oh.
try it for the video, but we want to know what percentage of students do drugs. Yeah, I'll just sit right there. So means, proportions, percentage is proportion, average height of students to be mean. So I don't think it's complicated, but I just want to make sure we're all in agreement on what it is. And then the next part is sample or population, which we've talked some about, but again, I just want to make sure it's like super clear what the difference is. Sample is like a spoonful of the soup. Population would be like the whole bowl of soup. So sample is like the little group that you're looking at. Population is the entire group. So then read through those 5 right there and tell me whether every underlined number is a sample or a population. So look at the first one. The median income is $45,000 in Milan. You take a random sample of 100 and find their median income. So this 45,000 is for all of Milan. Is that a sample or a population? That's population. And then the 100 people that I looked at, that's the sample, right? Let's do that for the next ones. Alright, so median income in the US is 45,000. That's population. At the homeless shelter, the median median income is 5,000. That's your sample. So sample is just like, again, it's like the spoonful of soup, and population is the cupful. The 50 females on stage, would that be sample or population? That would be your sample, and then the females at our school would be the population. So like every girl at our school, that's population, and if I take 50 of them and ask them a question, that is the sample. What kind of bias is that, if you read through that? What's that called? Nope. Response bias, that's response bias. So we think that our AP Stats class is smarter than the rest of the school. I don't know about that, but would the stats class be the sample or the population? The sample and the school's population. 51% of all people in the world are female. Is that 51% population or sample? It's population. Alright. So it's sampling distribution, and this is like the main kind of point I want to get through today. I want to do it on the board, but can't really. So I'm going to take 5 numbers. I'm going to go 0, 9, 18, 27, 36. So this is a data set. Like, say I asked 5 people how much money is in their wallet, and this is what I got. $0, $9, $18. So there's a big point I'm trying to make here. So let me kind of explain that first, then I'll use the numbers to talk about it. Let's say 2 people in here got a 30 or higher on ACT. You guys didn't take ACT. I might take ACT. 1%, okay. Alright, let's go to SAT. Let's say 2 people got a 700 or higher on like the math SAT. Alright? In this room. What is, okay, that would mean, so there's like 20 people in here. 2 of them got a 700 or higher. So if I randomly, like I put all the new names in the hat, makes myself pull one out, what's the probability that I get someone with a 700 or higher?
You said out of 30 people?
20 people. 2 out of 20 people, so 10%, right? Now, this is the main point I'm trying to make. If I take 2 names, let's say, and I average their scores together, does that make it more likely that we'll be over 700, or would that make it less likely that we'll be over 700?
Less likely.
It's going to be less likely, because now you need both of them to be high, right? What if I wanted to take 10 names, and then average it to be over 700? That's going to be like way less likely, right? So extreme values, the more often you do something, the harder it is to get an extreme value. Think about the lottery. Could I play the lottery once and win?
Yes.
So let me ask you this. What am I more likely to do? Play the lottery once and win? Or play the lottery 3 times and win all 3 times? Once, right? So the more, if you're trying to do something unusual, the more often you do it, the harder it is to do that unusual thing. What do I mean by unusual? What stats word do we use to talk about unusual? Outlier. How would we look at that? Outliers. Good. let's start looking at this, and that's enough to like start my point. I guess. Oh, that's fine. So what I want you to do is we're gonna do a sampling distribution. This would never happen. Like this is not a thing that anyone would actually do, but you need to understand what it is. So we're gonna take a sampling distribution of size n equals 3. What that means is we're going to take every possible combination of 3 of those numbers. Then we're going to find the average of each of those sets of 3. Then we're going to find the average of those averages. That's not that bad. So like 0, 9, 18. That's the first set of 3, right? And then I would probably go 0, 9, 27, 0, 9, 36. There are 10 of them. I want you to find all 10 of the possible combinations of 3, and then find the average of each one of those. Does that make sense what I'm asking? So like the first group of 3 would be 0, 9, 18. What's the average of those 3 numbers? That's an average. So then the 0, 9, 27, you add those up, you get 36 divided by 3, that average is 12. I want you to keep going and do that with all 10 of the possible combinations. Does that make sense what I'm asking? Joel, you don't look pleased. Oh, yeah, there is one, yeah. If you want to get through this quick enough, you'll do what I tell you.
Yeah.
This is like, the point is that you're going to see something as a result of this, and we're going to try to learn something here, Mr. Hill. You don't want to learn? It's not plus 3 every time.
What? You just said it twice.
And you listened?
I'm gonna see. Oh, she thinks what?
It might be at the beginning, but
Yeah, exactly.
I understand what you're saying, but that just doesn't really make sense.
Zach said it.
No, you did.
how about we shut up and do it?
How many are there supposed to be?
10. That's 5, choose 3. You don't really have to know that, but when we did the Pascal's triangle thing, that's how we figured it out. Just in case Joel doesn't care, I know, but just in case someone else cares. What'd you say? Yes. Right? Is Emily absent? She didn't drop, did she? She's just absent. expect anyone to. What?
Yeah.
In Calc?
Yeah.
Your paperwork is still being filed.
It's pending.
Yeah. League office still has to approve it.
Yeah.
So then I want you to go back to this number line and plot these new averages, the 10 averages that you found, on the same number line as those original 5 points. Does that make sense? So I'm going to put 9 on the number. I'm just going to go like a row higher. Put 9 up there, 12, 15, 15 again, 18, 21. See what I'm doing? So finish that. And then this is like the entire point I'm trying to make. If you can fill in that underlined blank, then you get what I'm trying to say. If you don't, I'll say it in a second. But I'm worried Joel's gonna yell at me, so I'm trying to just get it all out there. I should do this too. So imagine these are ACT scores. ACT is out of 36. Do you guys even know like what the ACT is out of or anything? Like is that just totally skip your grade? Like 36 is the highest, yeah. So you're like kind of aware of it, but I mean, it doesn't matter. 36 is the highest score you can get in the ACT. Someone here got one like 3 years ago, Christian Miller. There's been a couple 35s, but he went to Harvard. He took a year off, and I don't know what's happened since. Yeah, I hope so. I know it was.
You know what he went there
Turns out Harvard's hard. Political science, I think.
Yeah. I think it's a thing actually at Harvard where they want you to have like a year and then they want you to take a year off.
Really?
I think they do. I'm not sure, but
I could see that. That's what I heard too. He got like a B and like thought he was yeah. Okay. So this is 5 people in a classroom, and this is their ACT scores. So this is Christian Miller. This is like probably where most of you would be. This is like a little below average. This is, I don't know what I got. This is what Caleb got. So it's the same idea. If I want to take one person, I'm going to randomly choose one of these 5 people. What's the probability that that person got a 36?
if they're not Christian Miller, 0.
This is the only 5. Forget we did this. This is the only 5 people in the room. I'm going to put their names in a hat, pick one out. What's the probability that I pick out the person that got a 36? 1/5, right? Well, now I'm taking samples of size 3. What has to happen is your data has to condense. Because we're averaging in numbers. So is it possible to take 3 of these people and have those 3 average a 36? I couldn't even do that, right? So the highest a single person could be is 36, but the highest the average of 3 people could be is only 27. Same idea on the other end. The lowest one person could be is 0. The lowest the average of 3 of them could be is 9. So when you start increasing the sample size, your data shrinks down. It gets more condensed. You can't get outliers. When you start taking more a bigger sample, it's just really, really hard to get an outlier because everything just condenses toward the middle. Does that make sense what I'm saying? That's like the point I'm trying to make. So what does the standard deviation do? As I increase sample size, standard deviation shrinks or decreases. What about the mean? The mean of both of those would be 18. Like right in the middle of the dots on the bottom is 18. Right in the middle of the dots on the top is 18. So the mean stays the same.
What was that fancy word for it?
For what?
When we were doing spreads of graphs, whenever where the mean would stay the same, but the median would change. Or no, the median
Oh, so the mean is resistant? Is that what you're trying to say?
It's the fancy word.
Well, so that's for like new data though. This isn't new data. It's just like reshaping. So it's not really technically the same, but I see where you're going. Okay. This is kind of like the main notes for the chapter, actually, these two right here. So if a population has a mean of, how do I represent population mean? If I want to write that as a letter. What's population mean? Mu. It's mu. How hard is that? Population mean. I wanted like more than one person to say it. And a standard deviation, so we'd write it like this. That's sigma. Then any random sample chosen from that population has a mean of, so we would say x bar, but it's true in this case that mu and x bar are equal. Like the sample and the population will have the same mean. Because the mean didn't change when we did that thing with the 8 and the 9 and 27, all that stuff, right? The mean didn't change. The standard deviation went down, and it goes down specifically, it would become the standard deviation of the population divided by the square root of n. So if I multiplied my sample by 4, so I went from taking a sample of 10 people to 40 people, and I made the bottom 4 times bigger, what would happen to the standard deviation? It would shrink by how much? By 2, because you'd have to square root it. So like if I made the population 9 times bigger, or the sample 9 times bigger, then the standard deviation would shrink by 3, because there's that square root there. So it's not like 4 and 4, it's like 4 and 2 and 9 and 3. Does that make sense? What? It does make sense. Okay. Okay. So this one down here, what did I change? Looks like almost the same sentence. What did I change? Proportions instead of means. And that's the whole game from here on out. Is this problem deal with means? Okay, then I'm going over here and following these rules. Is it dealing with proportions? Okay, then I'm going over here and doing this stuff. It's just like that's the first thing you got to do. So the population has a proportion of, population proportion. How do I represent that? P. It's right there! But you see where I'm getting the P from now? Okay.
I try to be like involved.
She said I tried to.
I try to just shout random things when I can. Like that's basically what you're saying. Then the population, any sample has a proportion of what? So how do I represent sample proportion? This is your chance. That one's P hat. And a standard deviation of, and you're not gonna know this, but this would be square root of P times Q over N. Remember what's Q? Like the opposite of P, right? Failing. Yeah. Okay, so standard deviation of a sample is also called the standard error. That's like a vocabulary thing that you have to know. So they'll say, what's the standard error of this sample? Or what's the standard error here? And you got to know. That is the standard deviation of the sample. So what is the standard error for X bar? So you should be able to kind of read through what we've done and fill that in. Like verbally first, if you want to wait to write it. I was getting there. I didn't hear you get there, though. I just heard you on the way.
Standard deviation divided by the square root of n.
Yes. So, standard error for x bar. Well, what does x bar tell you we're working with? Means or proportions? Means. You got it. Good. Yeah. 50-50 shot, or did you actually know that?
I actually knew it.
Okay.
But I
So we're dealing with means, because x bar, dealing with means. And then this means standard deviation. So the standard deviation of a sample mean, I'll put that up here too. Standard deviation of a sample, I don't know how to,
Wait,
okay, wait.
you gotta add it on.
Yeah, this chart doesn't work.
You gotta add it on the other axis. What's the standard error of p hat then? Standard deviation of what? So this is the square root of PQ over N. Does this chart make sense what I'm trying to give you here? Yeah.
So for means, if you have a sample mean, that's the mean, that's standard deviation. If you have a sample proportion, mean standard deviation. Okay. Let's look at examples. This is where, how are we going to use this, right? So the average bag of M&Ms was 25 M&Ms inside, so that's mu equals 25. And the standard deviation equals 3. Why did I choose mu instead of x bar? So average first of all, but why else? So I know I'm in this column because it's means, but why did I choose mu instead of x bar to write down? Because it's the whole bag. That's the population. That's the entire bag. Is that what you said? Okay. So there's 3 things that are going to happen here. Well, 2 things are going to happen here. I'm either taking 1, which you could look at as a sample size of 1. Like if you take a sample size of 1, what would happen to the standard deviation? If your n is 1, does it change the standard deviation? No, you divide by the square root of 1, right? So you can actually look at every single problem we do in here as a sample. And just, it's a sample of 1 would be like one way you could look at it. But if I look at part A, what's the probability a randomly selected bag has more than 28 M&Ms? I should have told you something else here. I should have told you they're approximately normal. We've done that problem or a problem like that 100 times this year. How do we do it? Apparently we haven't done enough. I want to know that the probability we get 28 or more. I know the mean, I know the standard deviation. I told you it was approximately normal, right? Like I told you late, but I still told you. Normal CDF, what comma what? Not 25. 28, comma 99999, whatever. So I want 28 and up, right? So you can put 28 to infinity, you can put 28 to 9 million, you can, I mean, just some big number. And then you're telling the calculator the mean and the standard deviation. And then you're labeling them. It's a free response. So go ahead and type those in. Or type that in, see what we get. 28 you don't have to label. What? Were you trying to contribute again? Are you thinking of NPK? So that's binomial. No, in normal, it's just mean and standard deviation. No, I know, but it's also been like 2 months since we did it, so. But now you do, right? Okay. Okay. So here's where the new lesson comes in. In part B, what's the difference? The average of what? The what? I'm taking a sample. So in part B, I'm taking a sample. That's like the entire point of this unit. is can I recognize, am I taking a sample or not? So in part A, we took a sample, if you want to look at it as a sample of one. We just took one bag. So I took a sample of one if you want, or you can just use normal CDF. Part B, the only thing that changes, so I still want to know the probability that we are above 28. So it's still from 28 to 999. The mean is still 25. But what's the standard deviation? I took a sample. What happens to standard deviations when you take a sample? It gets closer together, right? It shrinks down that standard deviation. And by how much? Like, what's the formula? 3 over root 25. So, and you can just type in, I mean, yeah, you can put 3/5, but you can just type in 3 over root 25, and it'll do it for you. But this right here is the only difference between these two problems. This is not a sample, or it's a sample of 1. If you just want it every time, I'm going to divide by how many bags I took or whatever. But as soon as you take a sample, you have to, your standard deviation has to get smaller, and you have to use that formula. All right. So we'll type that in and see what we get. Wait, hold on. Don't type it in. Don't type it in. Don't type it in. Is that number going to be bigger or smaller? Smaller, because it's harder to be far away from the mean if you start taking more numbers, right? Because everything condenses. Good. Did you guys know why it was smaller, or did you just say it because you already got a smaller number? So this is basically 0. So I get 2.87 times e to the negative 7. That means move the decimal over 7 spots to the left, so you got 6 zeros. So this is basically 0. So I would put like approximately instead of equal. But, so could I get one bag that's like a lot bigger than we expect? Yes. But asking to get 3 that are all kind of averaging out to be bigger, that's tougher, because now your distribution's a lot smaller, and it's just hard to be an outlier. Right. Questions on number 1 there? Try number 2 on the next page.
Yeah, man.
Sorry. Sorry. Everyone said it.
Caleb said everyone yesterday. No one said anything. I say everyone today.
Well, there is like a bit of a history there.
Everyone does like this. Right, Caleb? I know.
They move their desk back.
Because they put their thumb.
That's why they don't care.
You know what? The second one might be. Yeah, this is like a
And I
very safe one.
also waited before everyone started like.
Yeah, that makes sense. I'll show you why.
Shut up, Caleb.
So now we're at like we're below the mean and looking up. So when we condense that data, we're actually picking up more of it. we're looking toward the middle instead of away from the middle. Does that make any sense?
Yeah, I see why it's more. I was just wondering.
Yeah, yeah. Alright, so part A. That is a randomly selected student. So it's one student. So is that a sample? I mean, if you want to say it's a sample of one, you can. But I would probably just say it's not a sample. But either way, so I'm going to go 130, 999. The mean is 150. The standard deviation is 10. Or, if you want to consider it a sample and tell me the standard deviation is 10 divided by the square root of 1, is that going to change anything? I mean, 10 divided by the square root of 1 is 10, right? So, I would look at it and say that's not a sample. Like, that's how my brain sees it. But if you see it as a sample of 1, there's nothing wrong with that either. So this comes out to 0.977. Did you guys get that? Okay, so now I want to kind of draw this out for you a little bit. So we've got an average of 150. Over here is 130. I'm looking for the percent of people that are above that. Well, then I took a sample. So what happens to that normal distribution hill or curve or whatever when I take a sample? It condenses, right? So that normal curve is going to be less spread out. So it's going to go more like this. Well, now what percent of the data is above that dotted line? More or less? So I'm looking this way now. Isn't it more? So earlier we said it's harder to be far away. But so if it's harder to be far away, isn't it easier to be toward the middle? That's the same exact thing, it's just phrasing it differently. So if I had a bunch of dots here, and I want to know what percent, and then I have my sample. So this is like the original data, this is like my sample. If I want to know what percent are above this line, because the data condensed, the sample has a better probability. If I want to know what percent are below this line, when the sample condenses, I have worse. So it's harder to be far away from the mean, it's easier to be active. Let's see, does that logically make sense to you? Okay. So the second one I think is 1 when you type it in, right? So it's normal CDF. Like everything's the same except for what? Except for the standard deviation is going to be 10 divided by the square root of, what am I take 50? Yeah. So I wouldn't even do the 7. I would just type in square root of 50, like when you're doing it. And it's not really 1, but it's so high, it just might as well be 1, is basically. Questions on, how many had those two? Yeah. Where? No, so it's the size of the sample. I took a sample of 50, and so that's n, and it's 10 divided by square root of n. Okay, I'm not, yeah, it might, but I still want you to be able to put the right thing in, you know? Yeah. Okay, so I shouldn't ask who got 1. How many had this exact equation is more what matters, I suppose. Okay. Alright, I don't think I've taught you enough to give you homework, so we'll just keep going on. I know that upsets you, right? You don't have to call me Jesus.
The percentage.
The amount after standard deviation, all that's left over is 0.5, right? 0.5%.